Lesson 1. Pressure and density of fluids. Reading guide. Key concepts. Essential questions. How do force and area affect pressure? How does pressure change with depth in the atmosphere and underwater? What factors affect the density of a fluid? Vocabulary. Fluid. Pressure. Atmospheric pressure. Inquiry. Why not straight? Have you ever noticed that dams are thicker at the bottom than they are at the top? Why do you think people build dams this way? What is a fluid? When people tell you to drink plenty of fluids when you play a sport, they usually are referring to water or other liquids. It may surprise you to know that gases, such as the oxygen and the nitrogen in the air, are fluids too. A fluid is any substance that can flow and take the shape of the container that holds it. Liquids. You probably have poured milk from a carton into a glass or a bowl. Milk, like other liquids, flows and takes the shape of its container. The volume of a liquid remains the same in any container. When you pour all the milk from a carton into a glass, the milk in the glass occupies the same volume it occupied in the carton. It just has a different shape. Gases. What happens when helium gas fills a balloon? If the balloon is long and thin, then the helium atoms flow into and fill the long, thin shape. If the balloon is spherical, then the helium atoms flow into and fill the spherical shape. Like liquids, helium is a fluid. It takes the shape of its container. However, unlike liquids, helium and other gases do not occupy the same volume in different containers. A gas fills its entire container, no matter the size of the container. Reading check. How are gases and liquids different? Pressure of fluids. Have you ever heard someone talk about the air pressure in a car tire or the water pressure on a deep-sea diver? What is pressure? Pressure is the amount of force per unit area applied to an object's surface. All fluids, both liquids and gases, apply pressure. The air around you is applying pressure on you right now. Pressure applied on an object by a fluid is related to the weight of the fluid. Like all forces, weight is measured in newtons, N. Pressure can be calculated using the equation below. In the equation, P is pressure, F is the force applied to a surface, and A is the surface area over which the force is applied. The unit measurement for pressure is the Pascal, PA. A dollar bill lying on your hand would apply a pressure of about 1 Pascal. A small carton of milk would apply about 1,000 Pascal. The direction of pressure. If the pressure applied by a fluid is related to the weight of the fluid, is the pressure only in the downward direction? No. A fluid applies pressure perpendicular to all sides of an object in contact with the fluid, as shown in Figure 1. Pressure and area. You read on the previous page that the amount of pressure on an object depends on the area over which a force is applied. If you tried to push the box of books shown in Figure 2 with one finger, your finger would probably bend. It might even hurt. Now, suppose you use your entire hand to push the box with the same force. Why is it easier? When you push a box with one finger, the force you apply spreads over a small area, the surface area of your fingertip. The pressure is great, and your finger hurts. If you push the box with your whole hand, you apply the same force, but the force is spread over a larger area. The pressure is less, and it is easier to push the box. Pressure decreases when the surface area over which a force is applied increases. Pressure increases when the surface area over which a force is applied decreases. Key concept check. How does pressure change as surface area changes? Pressure and depth. Have you ever dived underwater and felt pressure in your ears? The deeper you dive, the more pressure you feel, because pressure applied by a fluid increases with depth. Atmospheric pressure. Think of the air above you as a column that extends high into the atmosphere, as shown in Figure 3. The weight of the air in this column applies pressure downward. The ratio of the weight of all the air above you to your surface area is atmospheric pressure. At sea level, the atmospheric pressure on you and everything around you is about 100,000 Pascal, or 100 kPa. Now imagine you are on top of Mount Everest, nearly 9 kilometers above sea level, as shown in Figure 4. Atmospheric pressure is only about 33 kPa. The column of air above you is not as tall as it was at sea level. Therefore, the weight of the air applies less pressure downward. Atmospheric pressure increases as you hike down a mountain toward lower elevation. It decreases as you hike up to higher elevation. Key concept check. How does elevation affect atmospheric pressure? Underwater pressure. How does the pressure on the divers in Figure 4 change as the divers swim deeper? Underwater pressure depends on the sum of the weight of the column of air above an object and the weight of the column of water above the object. As a diver dives farther underwater, the air column above him or her stays the same, but the water column increases in height, and it weighs more. Underwater pressure increases with depth. At the deepest part of the ocean, the Mariana Trench, the pressure is 108,600 kPa, more than 1,000 times greater than pressure at the ocean's surface. Increased pressure with depth explains why the wall of a dam is thicker at the bottom than at the top. The water behind the dam applies more pressure to the bottom of the wall. Density of fluids. If you walked 10 meters down a hill, you would not feel a change in pressure. But if you dived 10 meters underwater, you would feel a big pressure change. Why is there more pressure underwater? The reason is density. If the volume of two fluids is the same, the fluid that weighs more is denser. A 10-meter column of water weighs about 1,000 times more than a 10-meter column of air. Therefore, the water column is denser. Calculating density. You can calculate density with the equation below, where D is density, M is mass, and V is volume. Density is often measured in grams per cubic centimeter, G/cm raised 3. The density of water is 1.0 grams per cubic centimeter. The density of air at 100 kPa is about 0.001 grams per cubic centimeter. Densities of different materials. Have you ever noticed that vinegar and oil form layers in a bottle of salad dressing? Each layer, such as those shown in Figure 5, has a different density. The density of a material is determined by the masses of the atoms, or the molecules that make up the material, and the distances between them. A penny is made mostly of zinc. One zinc atom has greater mass than an entire water molecule. Also, zinc atoms are closer together than the atoms are in a water molecule. Therefore, a penny is denser than water. Molecules in most solids are closer together than molecules in liquids or gases. Therefore, solids are usually denser than liquids or gases. Key concept check. What factors determine the density of fluids?